Hi, and welcome to our video on a review of exponents. The first thing we're going to talk about are what are exponents. And an exponent is basically just a way to write multiplication. So, for example, here A is the base, and B is the power that we are raising it to, which means how many times we're going to multiply A by itself. So A to the raised to the B power is really saying A times A times A, but we're multiplying A B times by itself. Another handy dandy tool is learning how to write roots as a fractional exponent. So the nth root of x could really be written as x raised to the 1 over n power. Finally, you're also familiar with the reciprocals. So 1 over x to the n really means x raised to the negative n power. So that negative exponent just tells me that I'm looking at the reciprocal. We're going to do a couple practice problems together, and then you're going to try some yourself. So we're going to try to simplify and rewrite each of these expressions using only positive exponents. In number 1, I see that I have the cube root of x. And as I recall from the second formula we were learning, I can rewrite the cube root as x raised to the 3rd power. So I could really write that as x to the 3rd. As we go on to number 2, when I look at y raised to the negative 2 power, again, that negative tells me I'm going to look at just the reciprocal. So I'll write 1 over y squared. Pause the video now and go ahead and try numbers 3 through 6. All right, welcome back, and you can go ahead and check your answers, making sure that you solve them correctly. All right, let's try some evaluation problems. Number 7, 8, and 9. 100 raised to the 1/2 exponent. Again, that half exponent really means the square root. It's the nth root. So this is really the square root of 100, and I know that that must be 10. If we look at number 8, notice that what's being raised to the negative 2 power, or the base, is just 5. The negative is not part of this exponent, and so I'm just going to leave that there because I can't, it's not part of the exponent. The 5, however, we're raised to the negative 2 power, which really means that we're going to write it as the reciprocal, and it's 5 squared. So this could be simplified to negative 1 over 25. Go ahead and look at number 9 and try it for yourself. As you can tell, number 9 is a little bit different because the base is not just 5, but the parentheses tell me that the base is negative 5. So when I am actually writing this, I need to remember the entire base is negative 5. Again, the negative exponent here tells me that I can rewrite this as 1 over the quantity negative 5 raised to the 2 power. Now I know that I'm actually squaring negative 5, not just 5, and so a negative 5 times negative 5 will still give me a positive. So this is 1 over 25. And if we look at number 8 and 9, and we can see our answers, they're different because those parentheses really tell me something else is going on. So it's really important to be careful with those parentheses. Let's go on, and we're going to now look at how to multiply and divide powers. As we all know, x to the 5th really means that I'm multiplying x by itself 5 times. If I multiply x to the 5th times x cubed, the x cubed again tells me I'm multiplying x by itself 3 times. But if I counted up all of the times that I am multiplying x by itself, I would have 1, 2, 3, 4, 5, 6, 7, 8. So x to the fifth times x to the 3 power would really be x to the 8 power. And if you notice, actually, we've added the powers, so the exponents. So we've added 5 plus 3, that gave us 8. So the rule tells me x to the a times x to the b power. Notice these have the same base. I can rewrite this as x raised to the a plus b power. All right, now let's try to divide. And you might already know in your mind what this will equate to or analogize to. We've got x to the fifth, so I've written out an expanded x to the fifth, divided by x to the x cubed. So I've also rewritten that on the bottom in the fraction. Notice that each of these x's will cancel out because they're both in the numerator and denominator, so you can factor it out. And we're left with just x squared. So what have we done with the powers? Well, we have subtracted. So again, since it has the same base, it's both x raised to some power, x to the a over x to the b will reduce to x to the a minus b. This is the law. And finally, I want to look at one last example. I've got x to the a times y to the b. And you'll notice something a little bit different here. My bases are different. So I cannot apply the same rules that I was using before. And in fact, I cannot simplify this anymore as it has already been written. So I will just rewrite this as x to the a times y to the b power. So let's try to apply some of these laws to some of these examples. Looking at number 10, we've got 3x to the fourth power multiplied by negative 2 times x squared. First thing I'm going to do is multiply the constants. 3 times negative 2 gives me negative 6. And then I'm multiplying x to the fourth times x squared. And I notice again it's got the same base, which means in fact I can combine these exponents. So that really means x to the 4 plus 2 power, which equals negative 6 x to the 6th power. Let's continue on to number 11. Notice in the numerator we are all multiplying. We have x times a times x raised to the 3 minus 2k power. X by itself is raised to the exponent of 1. So I could write in an invisible 1 if that helps me to visualize it. And in the numerator, let's combine all the powers of x first. I have x to the first power and x to the 3 minus 2k. Since I'm multiplying, my rule tells me that I add the exponents. Nothing happens to the a, so I've got x raised to the 1 plus 3 minus 2k, or 4 minus 2k power. And in the denominator, still have x raised to the 5k power. I can't touch the a, but again, I still have the same base for x. And so with the exponents, since I'm dividing now, I will subtract the exponents. So a times x raised to the 4 minus 2k minus 5k power. And I can simplify the exponent, so that would be a times x to the 4 minus 7k power. Pause the video now and try 12 through 15. Welcome back. Hopefully you've checked your answers now. You'll notice in number 15, Even though we have fractional exponents, the rules still work. So I have a raised to the 3/2 power and divided by a to the first power. So I subtract because I'm dividing. So 3/2 minus 1 leaves me with only 1/2. And we know that a to the 1/2 power is really the square root of a. All right, great job. And let's move on to our final topic, which is looking at powers of powers. So this is when I'm taking an exponent and I'm actually raising it to another power. So I have the quantity ax squared raised to cubed. So what does cubed really mean? Well, it means I'm going to multiply whatever's in that parentheses by itself 3 times. So I've written it out here so that we can try to generalize a rule. Well, let's look. We've got a total of 3 a's multiplied by itself, and I can write that as a cubed. And then I've got x squared times x squared times x squared. And as we learned in our previous in the previous law, we said that we would add the exponents. So this really is x to the 2 plus 2 plus 2 power, which gives us 6.
Asia White, please come to the main office right away to pick up an important delivery. Thank you. Also, I need Claire Page to the main office. You have a very important delivery here too, please, right now.
Sorry for that interruption, guys. Anyway, so we were talking about trying to generalize a rule. And if you notice, we've actually multiplied the exponents. So the 2 has now been multiplied by the 3, so we get a total of x to the 6th power. And that is the law of raising a power to a power. So if we go down to our rule box, x to the a raised to the b power, I will multiply the exponents. So x to the a times b. And notice even in the parentheses, it does distribute. So in fact, the 3 was also multiplied by the invisible 1 that the a is being raised to. So in my next rule or example, I want us to notice that this b will actually, in a sense, distribute to both the x to the a and the y to the c, because we're all multiplying here. And if we're always multiplying in that base, then this would work. So this is really x to the a times b power times y to the b times c power. However, if we look at our next example, which is x plus y raised to the 3rd power, I want us to think carefully again back to the definition of what an exponent means. The 3 doesn't mean that it's necessarily going to distribute and say x cubed plus y cubed. But what it really means is that I'm taking whatever my base is, and I'm going to multiply it by itself 3 times. That's what the 3 means. So let's write that out. We've got the quantity x plus y times the quantity x plus y multiplied by the quantity x plus y. Now we've got it 3 times. And if I look at this, I realize, you know what? I can't just, quote, distribute that 3. I would have to look at my binomial theorem, as we learned from last unit, and actually FOIL out and distribute this multiplication. And from the binomial theorem, I know that I will end up with x cubed plus 3 choose 1, which is 3, x squared y plus 3xy squared plus y cubed. So in fact, that exponent, we cannot apply this law to something like this over addition. I know some of you guys from Algebra 2 remember that it's, you can't break up that family. So that's one way to think about it. So x plus a raised to the n power, this is where I would have to use the binomial theorem. All right, let's try to simplify and combine some of these exponents. So the first thing is we remember in number 16, the 5 will distribute to everything that's being multiplied. So in there I've got 3 to the 5th power divided by as well a to the 5th power, and b, wait, b is raised to the x power. So what do I do to these exponents? I've got to multiply them. So this is b raised to the 5 times x power, so 5x. All right, let's try number 19 together. Again, we are raising everything to the 4th power, so we're going to multiply. And we're going to raise 1/2 to the 4th power times a to the negative 1/2 times the 4th power, so negative 1/2 times 4 gives me -2. I can even distribute it in this fraction. 1 to the 4th will just give me 1 though. 2 to the 4th, however, is a handy dandy number. 2 times 2 times 2 times 2, so that gives me 16. And then a to the -2 power. Let's think back carefully. What does that negative tell me to do? Tells me I'm going to be dividing. It's the reciprocal, so it's really 16a squared. And there's another way to write that expression. All right, let's do one last example together, and I'm letting you loose. So number 22. First thing, my recommendation is to write everything as an exponent. So let's combine things that are within the parentheses first. So the square root of 5 I can actually write as 5 raised to the 1/2 power. I have an a in the numerator and an a cubed in the denominator. So it might make it easier for me to cancel out this a and say, well, this is really raised to the 2 power. So it's the a squared in the denominator, and then we're going to raise all of that to the 5th power. Let's distribute this out, and we've got 5 raised to the 5/2 power times b to the 5x divided by a to the 2 times 5, so that's a to the 10th power. All right, go ahead and pause the video and try number 17 through 24. Welcome back. I'm putting up the answers. And I want you to notice, especially in number 18, we cannot simplify x minus 1 raised to the a power any further, since we don't know how much a is. And we can't distribute across that addition. So be really careful on that problem. And here's number 20. Don't be afraid of those fractional exponents. They are your friends. Notice in this last one we haven't talked that much about e, but it's still a common base, so we can still combine those exponents. And finally, in number 24, we've got x raised to the 3 plus a power, because again, we will multiply in that distribution, and we need to add those exponents then. Then we're going to distribute again, and we'll have negative minus x to the a minus 1 power. And we'll distribute one final time. And again, it's the same base still, so this is x raised to the a plus 1/2 power. And that finishes up 17 through 24. So our last couple of problems on the page. What we are doing now is rewriting these expressions in terms of the powers of 5. So we're going to apply all of those laws. And this will really prepare us for our next unit on logarithms and exponents. So I've got the cube root of 25. My first goal here is let's go ahead and write 25 as a power of 5. Well, I know 25 is really 5 squared. So now we've got the cube root of 5 squared. Another way of thinking about that is it's raised to the fractional exponent 1/3 So this is 5 raised to the 2/3 power. Go ahead and try 20 and 21 on your own now. All right, well, that concludes our video for today. Thanks for watching. I hope you guys have a better understanding of exponents and logarithms now.